Hey all, welcome back to the lab. In this video, we're going to discuss how to checkpoint code projects with AI agents, save your work, keep projects on track, and reduce rework. So I've been power coding with Claude Code the past couple months and have been reading up on best practices for working with AI agents. Now, one of the most common pitfalls that I see from newcomers is their painful experiences bricking their systems and losing all of their work. The solution to this is simple. Add checkpoints, and here I'll explain the various kinds of checkpoints that are useful in code projects and how to implement them. I think it's funny when I see people do this because it kind of reminds me of people who are new to video games and they start playing the game. And I guess this really only happened on older video games, but you'd play the game and then you'd keep going, and then the first or second boss, they would just die and get killed, and then they'd lose all their progress because they never thought to create a save game. And it's so second nature to people who have been gaming for a while, save anytime you get a good drop, save before you fight the boss, because you know how painful it's going to be if you didn't do that to have to go and redo that thing. That's the pain these people are feeling. And so this is basically going to be the equivalent of that for code projects. So first off, what is a checkpoint? So a checkpoint is a snapshot of your progress at a point in time. This is useful for saving system progress so that if and when you implement a bug, you always have a good state to roll back to. Now, there are two kinds of checkpoints that I think are useful when working with AI agents. We first have code checkpoints, and we next have project checkpoints. So a code checkpoint is like a save in a game. A code checkpoint is similar to a save in a video game. It's a save point you can load back to at a later date if a problem occurs and you want to boot up a safe copy. This is useful as there will be bugs, so sometimes it's easiest to roll back and start over, perhaps with a new prompt, than to try and fix what happened. With code checkpoints, you only need to roll back to your last save, or maybe the save before the last save. You don't have to start the whole game over, losing hours or even days of your work. And this is in RPG games, especially ones with, randomness, chance, and drops. As soon as you get a good drop, you might want to save just so you don't have to go back previously, or if you die, you might not get the cool weapon or whatever. But even maybe a better similarity is in RPG games where you have decisions and conversations or decisions and quests you can make, and you make one thinking it will bring you to the outcome that you want, but you realize down the line, oh no, that kills off my favorite character, or that blocks off an ending that I wanted, or it doesn't let me get to some item I wanted. Something you can't foresee, even though you went several steps ahead. Having that save point allows you to go back and redo the steps to get the outcome you wanted, which is going to be very similar to building a system, because sometimes you don't know that the approach you're taking isn't going to work until you've built most of the feature or tried several things on top of each other before you realize that's not where I want to go with this. So the code checkpoints are like those save games. They allow you to go back to whichever one you want, so you can redo those decisions from a safe place, not restart the whole thing. And a project checkpoint is like a quest tracker. So a project checkpoint is more similar to a quest list and tracker. It's useful for understanding where you are in the game as a whole, what the goal is, and what your progress is towards that goal. This is useful for AI because they hallucinate. The longer they work on something and the more context they get, the greater their chance to start diverging from the initial prompts. By providing them with project checkpoints, we allow them to focus on one thing at a time and lower the rate of them going off track. Now, this is particularly useful with AI agents, where the big unlock is allowing them to work independently on large tasks for an extended period of time. If they go off track all the time, then the work they produce will be useless, rendering the benefits moot. It's like asking little kids to do something useful, they'll just play around. You'll give them unlimited time and they'll never actually get the thing done because you can't really trust them to do it. And so therefore, just because they can do it, it's not going to actually happen. So it's just not useful. And the same is with AI agents. If we don't give them enough direction, they're going to go do something, but it's not going to be the thing that we asked or wanted for them to do. But if we can give them enough context to do that, now that extra time is actually very valuable to us because we don't have to look over their shoulder. They can do it, and then we come back to it and it's done. That's how we save time with AI agents. All right, so how to implement code checkpoints. Some IDEs and AI tools have checkpointing built in. So if they have that, you should use it. They're usually going to be pretty decent. They'll probably be well integrated with the tool stack, so we might have a good, UX experience or something. But I don't think you should only use that. And I think there's a better version overall out there. And so I think you should use another version of checkpointing that is more powerful and gives you more control of your checkpoints. And this is a checkpointing system that software engineers have been using effectively for decades: version control. Git is the current leading version control system, and so you should start with that. It works on every platform, and most IDEs have built-in tools for it, so you shouldn't have to install or configure much. Not to mention it, works with GitHub and Bitbucket and GitLab and like all the places you're probably going to find and interact with code anyway. And there's so many platforms out there that are used to actually, build and host code that have integrations for these Git repo services. And so if you just lean into Git, you're going to have all the tools that you could possibly want there. And so if this is your first version control system, highly recommend Git. Now, in its simplest form, Git allows you to construct branches of saves. And this isn't really a thing in video games, although it could honestly be very useful for them to implement save branching. But you could imagine that in those kind of like RPGs we talked about, if you could, at a pivotal decision and you're maybe not sure which route you should go and you're not going to know till later in the game because you don't want to like look up the story or something, where you start at a pivotal position, so you take a save, and then you're like, I can go one of two ways, and then you're basically going to go each way, and you might take a save at the next one and the next one before you find out whatever it is. And this will allow you to, at any point, go to any of these saves to roll back to figure out what the other ones are. And so it's like the same character, but you now have the ability to check out different versions of their, future, if you will, or any of those checkpoints of the different branch starting from that decision. And that's kind of what branched commits are. And so one way that like a lot of video gamers do this is they just like kind of name it something in particular. It might be like your character name with like, maybe you're playing a good character, so it's character name good and then character name bad, and then you'll preface all of your saves that way, so you remember like, oh, this is that playthrough. It's kind of like that if it had a nice UI and was easier to see, all of these saves belong to this one branch. I don't know if that description helps or not if you're new to Git, but that's kind of how I would think of it in video game terms. And so because you have this like history of branching saves, if you will, at any time you can create a new save in your branch. You can also create a new branch of saves, or you can load an old save, whether that's in your branch or in a different branch that you're interested in. And so these branches can also be merged together later, which is useful if you have multiple people working on different parts of a project and want all of that work to be brought together. This doesn't really work in like the video game metaphor, because video games more or less are like linear, and so you can't like combine things. The closest this would be is if you're playing like a factory building game like Factorio or something, and you built over in the northeast corner and your friend was like doing stuff in the southwest, and then you were able to somehow merge those two saves together. That's the closest we can kind of get with this metaphor to kind of what Git's doing. And so some of the game terms to Git equivalents, saving your game is going to be like doing a Git commit, loading a save is going to be like a Git checkout, and then branching is literally called branch in Git. And now an intro to Git is beyond the scope of this post, even though I've tried to describe this as best I can and these video game terms here, but there are plenty of guides online that can get you started. Now, as for how I use Git in my AI workflows, I like to follow the power coding philosophy of being an active contributor with the AI. I find this leads to better outcomes and fewer bugs, which leads to more efficient coding overall. And so my checkpointing system basically goes like this. I'll give AI an atomic task, I'll review the code and make changes, and then if I get to a place that I like, it's doing the thing I asked, it's made solid progress to this, then I'll make a checkpoint or commit. And then if I'm working in a team, this is the point when I would consider making a PR. I like doing atomic commits, which means that, every commit is basically doing one useful thing, one milestone of the task or project. And so I'd push this up for review by the team before it actually gets merged into main. But if I'm working on a side project or something, I usually just push to main, don't even worry about this. And then finally, I'll just continue to the next task. So that's code checkpoints. Now let's talk about how to implement project checkpoints. And so code checkpoints helps us with saving progress on all of our individual tasks, but we will still need some way to think about our project as a whole. After all, each task should be helping some project move to completion. This is especially important for AIs due to the hallucination issue and how much more context is required for a project as a whole versus a single task within it. When hallucinations happen, we'll typically need to create a new AI session to reset them to the important context. So if you don't have a project checkpoint available, it's going to take a lot of prompts and tokens to onboard the new AI to the appropriate context. And so basically, you get a new AI session and it's going to be blank, right? Like it'll read your agents.md, it'll get general things about your thing, about your project, but it won't know anything about your task. And so if the only way that you were teaching the last AI what it needs to do for your task was prompting, now you're going to have to start all that over. So that's going to include the primary prompt you did to start off the session, but also any of the clarifications you made throughout of like telling it, oh, don't do it this way, do it this way. All of that's going to be lost. And so that means the next time that you're making the new session, you're going to have to retype everything, and then you're probably going to miss something, right? And so what we want to do is find a way where we have that project checkpoint available so that when we spin up a new AI, we're just like, hey, go figure out the task. Like, here's the task instructions, go get started, and it can just do it. That's going to save us a lot of time and be more accurate overall. And so this is where project checkpoints come in. They're basically going to be quest trackers where we lay out goals of progress so that any AI that comes in can understand what they need to do, what's already been done, and what they should work on next without reprompting everything. And this is still useful even, in our video game analogy. If we go and load back a save somewhere, we're going to maybe remember a bit of context about that save because maybe we'll have something in the description that says like what is this save and where we are, but we're not going to remember the whole like state of the world in the video game. And so this is where quest trackers are super useful because we're like, oh, have we finished all these quests yet? Have we gotten these items yet? What is the next thing we need to do to like complete this branch of the story? And if we only have save games, it's going to be really hard to do that. That's why basically every video game has these things, challenges, quest lists and stuff, so you know where you are in the grand scheme of things. And so I implement project checkpoints with 2 to 3 docs depending on the size of the project. So for sufficiently large projects, I use an RFC or request for comments. This is usually for projects that are spanning many tasks, people, and or teams. And so they're going to need an extra layer of project planning, an extra layer of progress tracking, alignment, things like that. These will get RFCs. For individual tasks, I use a task description markdown file. This will be describing the context and the work that needs to be done. And then for the AI, I usually make it create a task tracking markdown file where it's going to note down what it understands it needs to do and what progress it's made so far. So let's talk through each of these. So RFCs are useful for keeping projects and humans on track. If you've ever worked at a company building software, you've probably read and written RFCs. An RFC, or request for comments, is basically a proposal to make some change. It could be a large feature, a new product, or a large tech migration. They usually contain things like, the business context, what problem we're trying to solve and why it matters, the solutions you propose, and a general plan for how to make that happen. Not every change is going to need a full RFC, but larger changes that need to work across multiple tasks and or teams often benefit from them as they can get people aligned on what we're trying to build. Knowing what you want to build and how is crucial for getting the most out of AI because that's how you're going to be able to give it better tasks, prompts, and reviews to reduce work. This RFC is basically the primary project checkpoint for humans, where we can see what we're trying to do, our progress, and what's next. And if there's ever a catastrophic problem with AI or our code base, we can always fall back on the RFC to get back on track. And for the video game metaphor, I would say this is kind of like the quest log or quest list itself, not an individual quest, but the list of all quests that you need to do and whether you've completed them or not. This is a lot of information, a lot of context, and AIs really cannot understand and plan this much. They're just going to hallucinate because there's too much context for them. And similarly, humans are going to forget things. That's why we write stuff down, because we can't hold all that context either. But we need a way to track what are the tasks, why are we doing them, what do they ladder up into, what quest line is this part of, have we failed the quest already, things like that give us a broad overview of what are we trying to even accomplish here so that we can get reoriented and we can understand how each of those individual quests, those individual tasks actually ladder up into something useful. The task description files allow for more detailed, reusable AI prompts. So most people prompt AI by typing into the chat box. That works, but is hard to systemize. If you spin up a new AI, you basically need to retype everything you already said, and as we talked about, that might include all the clarifications you made to the last AI to get it to stay on track, and you're probably going to forget about those, and so the new AI is going to have the same or similar problems. By instead writing our prompt in a file, we immediately get the ability to link that prompt to any new AI we spin up. This means that any extra details you provide aren't wasted or missed when you start a new session. And I found this was really frustrating to me, is I'd get the first AI on track and then it would get stuck and then I would spin up the next AI, but my next description would be a lot less descriptive because I was tired and irritated that I even had to prompt this thing again. And so that made the AI less effective because I didn't give it all the details it needed. And so when I do use these files, I do find myself typing up more descriptive prompts. One, because I know I only have to do it once. I'm not going to have to retype this later. It's not lost data. But it also allows me to review and iterate on what I've wrote. And I don't think any of us are super good and we can just one shot an essay or a task description. There's always going to be some things that were oh, I actually meant this or something like that. And just the fact that I can see it and I can review it and do another pass before I give it to the AI, I think makes the task description significantly better, which of course leads the AI to have significantly better outcomes because it has that better input. And I found it also allows me to provide better examples, like all these little chatbot things, like the chat windows are like small and they're kind of cramped, and like no one writes documentation like this. And so when you're trying to paste in, like, let's say a diff to be like, here, this is an example of how I fixed this in the past, to give it examples, it like quickly gets muddy, and the AIs are pretty good at munging this stuff, but it's just not the best experience. And I feel like typing things out in a file, which is how we type code, which is how I type my blog posts and stuff, just feels so much more natural to me as a way to convey information in text format. And so I provide more examples, I provide links to things better, which again, I think improves the input, that improves the output that the AI creates. Okay, and task tracking files help the AI stay on track. So if the task description is kind of like the overall quest description, then the task tracking file is how the AI tracks its progress. So it's like you've killed 5 out of 10 boars or something like that. And I usually make the AI write up its plan and track its progress in a new file. This will allow it to summarize what it understands and format its tracker how it wants. And this gives me another opportunity to review what it thinks it should do and course correct if I see something wrong. And this is helpful, before you just send the AI off and you wait 10, 20, 30 minutes, however long it takes, and come back to it and be like, oh, it did the whole wrong thing. You can just do a quick scan of what it thinks it should do, rearrange things, change up things if you need to. Or if it's like way off, you can go back and change your description to make it more clear what it needs to do and, create a new session with it, which again just saves time and saves rework, because you don't find out in 30 minutes, you now find out in 1 minute because you actually read what it thought it was supposed to do. I also found that it often will summarize things like commands and stuff from the other agents files that are scattered around and best practices and stuff like that, which I hypothesize is saving it tokens long term. I don't actually know if that's true or not. But certainly when you're spinning up a new AI session, it should help it get better context or better onboarded to context without having to read everything like the first one did. And so with the task description and tracking files in place, I'm never worried about spinning up a new AI session if the old one gets stuck. The new AI can catch up on what we're doing and where we are and start chugging away on the next task. And crucially, without me having to prompt everything again, I can literally just link the task and the task tracker, and it's good from there. Okay, so how I build software with AI agents and checkpointing. So that's a lot about the individual methods of checkpointing, and I want to bring this all back together into a cycle that I used to build with AI. And so the flow starts with creating an RFC at the beginning of the project to plan and track overall progress for me as a human, to share it with others. This is the project plan. This is the project management side of software that just needs to be done by someone, to be the human. Now, if the task is small and self-contained, I might just skip this step and just put the plan in the task description because it might not be worth this extra layer. Then once the plan's in place, I'll go do this for each task. So I'll first create a task description markdown file, and I'll often name it something like this, basically just a prefix of some code that I know is like mine. Maybe I'll do HAMY or HAMY to do, something that's clear in the git diff that like, oh, this shouldn't be committed to the code base. This is like personal notes for me. And then I always include a ticket ID so I know exactly what this thing is, so I can find it later if I'm ever looking for artifacts related to this. Then as part of the task description, or sometimes I do this as part of my agent's MD, is I'll have the AI create its own task tracking markdown file, and I'll have it name something like this, agent, so I know that this isn't my personal notes, but it belongs to an agent, but then I still have the ticket ID so I can find all of these together again if I want to. And then once that's in place, I'll iterate through the task with the AIs. So I'll give it the task description, task tracker, it'll code what it needs to, and sometimes I will prompt it to be like, oh, let's just do the next task, or if I'm batching tasks, I'll be like, let's do the next 5, or something like that. And then once it's done, I'll review and make changes. Similar to a code review, I'll give it feedback if it's done a lot of the same problem over and over so it can fix it. If it's just like one-off, I'll try to fix it. If it's stuck, I'll fix it myself. This is a very collaborative, review. And then whenever I'm happy with it, I'll commit and push. I think this is when atomic commits comes into play, as I think a lot of times people get into like weird states because they're maybe trying to do too much in a single commit. And so they do like most of one thing good and then part of another thing, but it's bad. And that's like an unstable save. It's kind of weird to push that because you know that the next one is going to have like a chunk of this. And so what I often try to do is get one task done really well at a time with AI, and then commit that so it's a really solid save before working on any chunk of the next thing. And then finally, when I've done that, I have AI updated to tracking doc with what we just did and where we are so that it can go and reliably pick up the next task. And when I'm feeling spicy, I will sometimes try to parallelize these tasks. So, after I have the plan done, I might start one AI on one of these, and then I might start another AI on one of these. And it's even better when I already have these available. And so I'm only iterating through the ticket. So if one's working on this, I can go work with another one to start its next task. I will say that it's been hit or miss because some tasks and some AIs need more help than the other ones. But I do feel like this capability is reasonably close on the horizon. Like I can always get one to reasonably do what I want. And then the second one has a little bit less of a chance. And if I have a third one, that one is just slower because I can't review as fast. But I feel like we're getting there. And I think this is going to be a pretty common workflow pretty soon. Next. So AI is an incredible tool, but we're still figuring out the best ways to work with it. I found that a lot of the best practices for getting the best out of AI are similar to the best practices for getting the best out of software engineers. Vibe engineering and power coding takes more active work short term than vibe coding, but it tends to end up with better outcomes and less rework, debugging and fixing problems, and so I find it ends up with higher throughput long term. If you have an AI collaboration process that's working for you, I would love to hear about it. You can comment below or message me on one of my socials. And if you like this post, you might also like Stop Vibe Coding, Start Power Coding, how to write quality software faster with agentic AI without pissing off your existing software engineers. You might also be interested in I vibe coded a C# library with Claude Code. Here's 6 things I learned. And finally, my career in programming languages. So that's it for this video. Thanks for watching, and I'll see you in the next one.